So much of machine learning seems to rely on having perfectly labeled data. But what happens when you don't? What if you just have a mountain of information with no labels at all? How do you start to find the structure hidden inside? This is a really common problem. You have all this raw data, but no predefined categories, no neat little tags to work with. The patterns are probably in there, but they're invisible to you. Well, that's exactly what an algorithm called k-means is for. And by the end of this explainer, you're going to have a really solid intuition for how it automatically finds those hidden groups for you.
Okay, to really get a feel for k-means, let's forget all the technical terms for a moment and start with a simple analogy.
Let's say you're a store manager. You've got data on all your customers, but you don't have any ready-made labels like budget shopper or luxury buyer. All you have are the raw numbers.
So for every customer, you might know just two things: their annual income and some kind of spending score. What you really want is to find the natural segments in that data. Are there a bunch of high-income, low-spending folks? Or maybe a group of low-income, high-spending customers? Finding these segments is gold. Now, if you were to plot all this data on a chart, you'd probably see these natural clumps forming. And just by looking at it, you could probably drop a pin right in the middle of each clump. Then you just say, okay, every customer belongs to whichever pin is closest. That simple idea right there, that's the core intuition of k-means. All right, now let's put some formal language on that intuition. There are just two key terms we need, and they map perfectly to our store analogy.
First up, what we were calling a group or a clump. The technical term is a cluster. It's just a collection of data points that are way more similar to each other than they are to points in any other cluster.
And that pin we dropped in the middle, that's called a centroid. You can think of it as the cluster's center of gravity, and it's calculated simply by averaging the positions of all the points inside that one cluster. So how does the algorithm actually find the best centroids? It does it through a clever, iterative process. First, it just guesses and plunks down a certain number of random centroids. Let's call it k. Then it repeats two steps over and over. Step 1, assign every single data point to its closest centroid. Step 2, move each centroid to the new average location of all the points just assigned to it. You just keep repeating those two steps until the centroids stop moving. People often call this the k-means dance. The centroids move toward the data. Then the data realigns with the new centroids. Back and forth until everything finally settles down and the groups become stable. And here's what that looks like in practice. You start with just a big, messy cloud of unlabeled dots. After k-means does its thing, you get these beautifully distinct, colored groups, each with its own defined center. The algorithm has found that hidden structure all on its own. Okay, so this isn't just some cool theoretical idea. K-means is a workhorse algorithm used in tons of real systems. So let's talk about where it actually matters. Its uses are all over the place. We've talked about customer segmentation, but it's also used for grouping similar documents together, for segmenting images based on pixel colors, and even for spotting unusual patterns in fraud detection. Here's a really clear, concrete example. Imagine you have a data set of houses, and for each one you only have its latitude and longitude. If you run k-means on just those coordinates, it'll start to find geographic clusters. The key thing is, the algorithm knows nothing about cities or zip codes. It's just finding dense groups of dots on a map. But here's where it gets really powerful. After you have those clusters, you can analyze them. You could, for instance, calculate the median house price for each cluster. And you'd probably discover that cluster 1 along the coast is way more expensive than cluster 2 in the valley. You've just uncovered distinct market segments that were completely hidden in the raw data.
So, to put it all into one sentence, k-means is an iterative algorithm that partitions unlabeled data into a specified number of clusters based on proximity to a central point.
The algorithm's simplicity is really its greatest strength, but it also leads to one absolutely crucial question. How do you know how many clusters to tell it to find in the first place? How do you choose the right k? Figuring that out is the key to using this tool effectively.